Bismillahirrahmanirrahim. Hello everyone, I hope you are all doing well. I welcome you all in class of Real Analysis by Robert G. Bartle. My name is Azmat Ali. In today's lecture, we will discuss solution of question number 14 and 15 from exercise 2.2, chapter number 2, the real numbers. These two questions are actually related to the graph of equations and inequalities. So let us start from question number 14. Question number 14 says determine and sketch the set of pairs xy in R cross R that satisfy the equation x absolute equal to y absolute. To solve this equation, the first method that I will use here, a given equation can be written as by dividing on both sides by x and assuming at the time of division your x is non-zero. So this can be written as y absolute over x absolute equal to 1. These two absolute can be combined in a single absolute. This can be written as y over x absolute equal to 1. And by definition of absolute, this becomes y over x is equal to plus minus 1. This gives two equations, y is equal to x or y is equal to minus x. And these are the two lines passes through the region, so x is equal to 0 is included now. The other way to solve this equation, that is very simple. We can take square on both sides. This gives square of x absolute equal to square of y absolute. You know, square of a absolute is simply equal to a square. So by using this result, we can write it as x square is equal to y square. And this becomes x square minus y square is equal to 0. And from here, we have x minus y into x plus y is equal to 1. And again, we have two equations, y is equal to x and y is equal to minus x. Okay. Next we discuss the first line, y is equal to x. This is a straight line, passes through the origin, bisecting first and third quadrant. Similarly, y is equal to minus x is a straight line, passes through the region and bisecting second and fourth quadrant. If you cannot directly observe the graph of these two lines, you can take any 2 to 5 pairs to draw or sketching these lines. But I think these are very simple lines. So the first line is y is equal to x that passes through the region is here, and second is y is equal to minus x that bisect the second and fourth quadrant. So this is the graph of x absolute equal to y absolute, and it complete first part. Next we move towards 14b. 14b is x absolute plus y absolute equal to 1. We discuss 4 cases here. When your x is greater than or equal to 0 and y is greater than or equal to 0. Then 1 becomes, as your x is greater than or equal to 0, so by definition of absolute, x absolute is equal to x. Similarly, y absolute is equal to y when your y is greater than or equal to 0. So question number 1 can be written as x plus y is equal to 1. I hope in your school level algebra, you know the two intercept form of line. Two intercept form of line. This is x over a plus y over b equal to 1. The number in the denominator of x is called x-intercept, and the number in the denominator of y is called y-intercept. So this represent x over 1 plus y over 1 equal to 1. So the number in the denominator of x is 1. So x-intercept is 1 and y-intercept is 1 also. How can we define x and y-intercept? Actually, x-intercept and y-intercept are the points where the line cuts x-axis in the x-axis and y-axis respectively. Now we discuss the second case when your x is less than or equal to 0, y is less than or equal to 0. Because your x is less than or equal to 0, in this case your x absolute is equal to minus x. And similarly, in case when your y is negative, your y absolute is equal to minus y. In case when your x and y is 0, then x absolute is equal to simply 0. In case of negative, x absolute is minus x and y absolute is minus y. So now one becomes minus x minus y equal to 1 by replacing x absolute equal to minus x and y absolute equal to minus y equal to 1. We can write it as x over minus 1 plus y over minus 1 equal to 1. This equation shows your x-intercept is minus 1 and your y-intercept is minus 1. Now case number 3, when your x is less than or equal to 0 but your y is greater than or equal to 0. Because here x is less than or equal to 0, so x absolute will be minus x and y absolute is equal to plus y equal to 1. This can be written as x over minus 1 plus y over 1 is equal to 1. Now your x-intercept is minus 1 and your y-intercept is 1. Last case, when your x is greater than or equal to 0 and your y is less than or equal to 0. As your x is greater than or equal to 0, so x absolute will be equal to plus x, but y absolute will be minus y. So this becomes x minus y equal to 1 and can be written as x over 1 plus y over minus 1 is equal to 1. Now your x-intercept is 1 and your y-intercept is minus 1. Next we draw all of the 4 lines by using their intercepts. We have 4 type of intercepts. Either your x-intercept is 1 or minus 1. Similarly, your y-intercept r1 is 1 or minus 1. So there are 4 types of intercept: 1 0, minus 1 0, 0 1 and 0 minus 1. This is my first intercept 1 0. This is my second intercept 0 1. This is my third intercept minus 1 0 and last is 0 minus 1. Now joining these intercept, the first intercept for this line has the 2 intercepts. X-intercept is 1 and y-intercept is also 1. So by joining these 2 points, we have the graph of this line x plus y is equal to 1 here. Similarly, when you join these 2 intercepts 0 1 and minus 1 0, in these 2 intercepts your x is negative and your y is positive. So this will be the graph of minus x plus y equal to 1. When you join these 2 intercepts 0 minus 1 and minus 1 0, in both of these intercepts are negative, so this will represent the graph of minus x minus y is equal to minus y, plus 1, sorry, this is plus 1. And the last one is the fourth side is x minus y is equal to 1, which can be made by joining the intercept 1 0 and 0 minus 1. Just a minute for processing. Okay, so this is the diamond shape, or you can say this is a tilted square. So graph of x absolute plus y absolute is equal to 1 is a diamond shape. Next, we move towards the C part. Interesting, xy absolute is equal to 2. By taking square on both sides, we have xy absolute square is equal to 2 square. This is 4. As you know, square of x absolute is simply square of x. So we can replace this quantity by x square into y square. Minus 4 equal to 0. By using the formula simple a square minus b square, which is equal to a minus b, a plus b, this can be written as xy minus 2, xy plus 2 is equal to 0. From here, either xy minus 2 is equal to 0 or xy plus 2 is equal to 0. This can be written as xy is equal to 2 or xy is equal to minus 2. From here, we have y is equal to 2 over x. And this is y is equal to minus 2 over x. These two curves represent actually a rectangular hyperbola. Y is equal to 2 over x represent a rectangular hyperbola, lies in first and third quadrant, while y is equal to minus 2 over x represent rectangular hyperbola, lies in second and fourth quadrant. Just for our convenience, we take some points x, y from R cross R to draw the graph of xy is equal xy absolute equal to 2. I am taking here 8 points, x is equal to plus minus 1, plus minus 2, plus minus 4, plus minus 8. By substituting these values of x in the first branch, y is equal to 2 by x, we have y is equal to plus minus 2. When you put x is equal to plus minus 1 here, this gives y is equal to plus minus 2. Similarly, when you put y is equal to x is equal to plus minus 2 here, this gives your y is equal to plus minus 1. And similarly, you can evaluate all other points. Lastly, when you put x is equal to plus minus 1, now your y is minus 2 by x. So it will reverse the sign. This becomes minus plus 2, minus plus 1, minus plus 1 by 2, minus plus 1 by 4. Minus plus mean, suppose when you put x is equal to 1, positive 1, in the second branch, your y will become minus 2 over 1, this is minus 2. When your x is positive, your y is negative. Similarly, when you put x is equal to minus 1, now your y will be positive 2. When your x is minus negative, your y is positive. So that's why these are the opposite sign to this sign. Next, after evaluating all of these points, we can plot all of these points by just taking, by scaling, we can make this graph. The graph in first and third quadrant, if I zoom out this graph, that's why you can okay, this is the full graph that you can make by just plotting all of the points. Suppose when your x is 1, y is 2, this is my first point. When your x is 2, y is 1, this is my second point. This is my third point, 4, 1, 2, and this is my last point. Similarly, I can plot all of the points in the third quadrant. After joining these points, first the graph of y is equal to 2 by x when x is positive lies in first quadrant, and graph of y is equal to 2 by x when x is negative in the third quadrant. So the graph of y is equal to 2 by x lies in first and third quadrant. It depends on x is positive or negative. Similarly, we have the graph of y is equal to minus 2 by x in second and fourth quadrant, depend on x is negative or positive. So this is the full picture of the graph of xy absolute equal to 2 here. Next we move its last part, and I will share the two different method to solve this question. The first method is actually the wrong method attempt by different students. I sever during checking the paper of students. I have observed that students commonly do this question as, and that is wrong. So this is the wrong attempt by students. Often students do this question as, they try to solve this question by using the method that we have discussed in 14 uh, 14b, that was x absolute plus y absolute equal to 1. In this question, we make two intercept form of this equation in different cases. So firstly we try to solve this question by using this method. Case number one, when your x is greater than or equal to 0, y is greater than or equal to 0. Because your both x and y are greater than or equal to 0, that's why your x absolute is equal to x and your y absolute is equal to y. So this equation x absolute minus y absolute equal to 2 for this case becomes x minus y is equal to 2, and this can be written as x over 2 plus y over minus 2 is equal to 1. So from here uh, we we take students take sometime, that is the actually mistake. Students take x is equal x intercept 2 and y intercept minus 2. Similarly, they consider the second case when your x is less than or equal to 0, y is less than or equal to 0. So in this case, your x absolute will be minus x and your y absolute will be minus y. This become minus x plus y equal to 2. And when you divide on both sides by 2, this becomes minus x by 2 plus y over 2 is equal to 1. Or it can be written as x over minus 2 plus y over 2 is equal to 1. This gives x intercept is minus 2 and y intercept is 2 here. Last case, when case number 3, sorry, when x is greater than equal to 0 and y is less than or equal to 0 here. Again, when your x is greater than equal to 0, the first value will be x and the second value will be minus y. This becomes x plus y is equal to 2. By dividing on both sides by 2 to make it 1, we have x over 2 plus y over 2 is equal to 1. This becomes x and y intercept is equal to 2 here. Case number 4, when your x is less than or equal to 0, your y is greater than equal to 0. 1 becomes minus x minus y is equal to 2. Can be written as x over minus 2 plus y over minus 2 is equal to 1. This gives x intercept minus 2 and y intercept minus 2 here. Next, we draw all of the 4 lines by using these intercepts. So if we join all of these intercepts again, we have a graph of x absolute minus y absolute is equal to root a diamond shape, which is wrong. Its graph is not a diamond shape. Actually, where is the mistake? Now we will discuss the actual mistake here. Now I give its correct version. Case number 1, you have considered x absolute x greater than or equal to 0, y greater than or equal to 0. Your equation number 1 becomes x minus y is equal to 2. By dividing on both sides, we have x by 2 plus y over minus 2 is equal to 1. If you compare this equation by two intercept form, which is x over a plus y over b is equal to 1, your x intercept is 2 and your y intercept is minus 2. But y is equal to minus 2 is not possible. This is the main reason. That's why the first method is wrong. Your y is equal to minus 2 is not possible because in this case, you have considered y greater than or equal to 0. So how is this possible that y is equal to minus 2 here? So as your y is greater than or equal to 0, so 0 minus 2 does not lies on this line. Although this point satisfied on this line, but for the restricted domain, you have restrict this domain that this is in this case your x must be greater than or equal to 0 and your y must be greater than or equal to 0. Both are non-negative. So y is equal to minus 2 algebraically satisfied this equation. If you put x is equal to 0, y is equal to minus 2, this is equal to 2, algebraically it's satisfied, but conceptually this does not satisfy this equation. So the first value of x for which y is greater than or equal to 0 is x is equal to 2. So in this case, we will draw the graph of this line for x is greater than or equal to 2, y is greater than or equal to 0. In other words, because I have to need non-negative y. So if I find the value of y from here, this becomes x minus 2 is equal to y. Now to find y greater than or equal to 0, which value of x will work here? We put x is equal to 2 here. When you put x is equal to 2 here, this becomes 2 minus 2, which is equal to 0. It means when you take x greater than or equal to 2, your y will be greater than or equal to 0. So this is the main mistake here. On the other hand, if you see question number 14b, there was no such problem in this question, because when you take x-intercept, x greater than or equal to 0, y greater than or equal to 0, your x-intercept and y-intercept both are greater than or equal to 1. So these intercepts are automatically satisfied for these cases. For example, when you consider second case, when your x is less than or equal to 0, y is less than or equal to 0, you can observe that both x and y intercept are less than 0. Similarly, when you consider third case, you can again observe that your both x and y intercept satisfy this case. That is, your x is minus 1, which is less than 0. Your y intercept is positive 1, greater than 0. So in this question, there is no such problems for x and y intercepts that appear in this question in D part. So when you have to find x and y intercept, you have also observed the restriction here. This is not just you will take the denominator and denominator of x and y, and you will say this is the x and y intercept. These intercepts should satisfy these cases also. Similarly, you can consider second other cases when your x is less than or equal to 0, y is less than or equal to 0. In this case, your given question number 1 become minus x plus y is equal to 2. And this gives x-intercept minus 2, y-intercept equal to 2 here. But y is equal to 2 is not possible here, because your y should be less than or equal to 0 in this case. It means 0 to this point does not lie on this line. For restricted domain, x less than or equal to 0, y less than or equal to 0. So y less than or equal to 0, when your x is less than or equal to minus 2 for this case. Mean to say, from here, if you find y, this become y is equal to 2 plus x. Now I want y should be less than or equal to 0. So when you put x less than or equal to minus 2, when you put x less than or equal to minus 2, your y will be negative. Otherwise, this is very simple. You want that your y should be less than or equal to 0. Put this number equal to less than or equal to 0. This gives x less than or equal to minus 2. So when your x is less than or equal to minus 2, your y less than or equal to 0. So this is the restricted domain, or the valid value of x and y to draw the graph of this equation, minus x plus y is equal to 2. The third case, suppose your x is less than or equal to 0, y is greater than or equal to 0. In this case, your equation becomes this. This equation gives x and y intercept minus 2, minus 2. But this number is not possible because your y is greater than or equal to 0. Now, as my y should be greater than or equal to 0, this equation can be written as minus x minus 2 is equal to y. I want my y should be greater than or equal to 0, so put y greater than or equal to 0. From here we have minus x minus 2 greater than or equal to 0. In other words, this can be written as minus x greater than or equal to 2. Multiply on both sides by minus 1. This gives x less than or equal to minus 2. So this is the valid value of x here. X less than or equal to minus 2, y greater than or equal to 0. Last case, when your x is greater than or equal to 0, y less than or equal to 0. In this case, we have x and y intercept. Both are equal to 2. But y is equal to 2 is not possible because my y is less than or equal to 0 here. Again, you will put here y is equal, this is y is equal to 2 minus x. My y should be less than or equal to 0. This become 2 minus x less than or equal to 0. From here, 2 is less than or equal to x. In other words, your x should be greater than or equal to 2 here. By using all of these four cases, we can draw the graph of this number, this equation, sorry. I have a two type of intercept. Either it is x2 y0 and this is minus 2 y0. There is a no intercept 0 2 or 0 minus 2. In other words, the graph never touch or cross the y-axis here. This is the first, starting from this intercept x2 y0. When your x is greater than or equal to 2 or y is greater than or equal to 0, this will give the graph of x minus y is equal to 2 here. Similarly, again, when you start from this intercept 2 0 and your x is greater than or equal to 2, y is less than or equal to 0, this will give the graph of x plus y equal to 2 here. Similarly, when you draw the graph from minus to 0, these are the two lines again, this and this. This is the graph minus x minus y equal to 0 is equal to 2 for x less than or equal to minus 2 and y greater than or equal to 0. And this is the graph of minus x plus y is equal to 2 when your x is less than or equal to minus 2, y is less than or equal to 0 here. Okay. Next, I give a very simple method to solve this equation without finding x and y intercepts. We can write it as y absolute is equal to x absolute minus 2. Case number 1, when your x is greater than or equal to 2. As your x is greater than or equal to 2, so in this case your x absolute will be equal to positive x. You know, when your x is greater than or equal to 0, then x absolute simply equal to plus x. So particularly when you say your x is greater than or equal to 2, then also your x absolute will be equal to plus x. So replace this x absolute equal to x. We have 1 become y absolute is equal to x minus 2. Now open the absolute value. This becomes y is equal to plus minus x minus 2. So from this case, we have two straight lines. Y is equal to x minus 2 and y is equal to minus x plus 2, starting from the point 2 0. And in the above method, you can also observe that we have two straight lines, x minus 2 and x minus x plus 2, starting from 2 0. From this point, you can observe that there are the two straight lines. First is x minus y is equal to 2 and second is x plus y is equal to 2. Case number 2. Suppose your x is less than or equal to minus 2 when your x is less than or equal to minus 2. In this case, your x absolute will be equal to minus x here. Your equation number 1 become y absolute is equal to minus x minus 2. This becomes plus minus minus x minus 2. So from this case, again we have two straight line. The first is y is equal to minus x minus 2 and the second one is y is equal to minus minus x minus 2. This can be written as x plus 2. Starting from the point x minus 2, y 0. Clearly, when you put x is equal to minus 2 here, your y will become 0 here. Your y is 0 here. Similarly, when you put x is equal to 2 here, again your y is 0. So there are the only x intercept for this curve. And remaining you can draw the graph of these four lines by using this way. Next we move towards question number 15. The question number 15 is actually the graph of inequalities. In this question we have to draw the graph of inequalities, and these inequalities are opposite to the equations available in question number 14. The statement of question is determine and sketch the set of pairs x, y in R cross R that satisfy this inequality. To draw the graph of this inequality, firstly I will find opposite associated equation. The associated equation of 1 is simply can be obtained by replacing less than or equal to sign with equal sign. So this one becomes x absolute equal to y absolute. Say this is my equation number 2. Graph of 2 we have already discussed in question number 14a part. Next, we have to take any test point inside the region enclosed by the line y is equal to x and y is equal to minus x, and check whether that point satisfies 1 or not. If point satisfies 1, then graph is inside the region enclosed by the line y is equal to plus minus x. The graph of x absolute is equal to y absolute is given by the two straight line y is equal to plus minus x. That was this is my first line, y is equal to x, y is equal to x, sorry, and this is my second line, y is equal to minus x. Now these two lines divide this plane into four parts. Suppose this is my first part, that is lies in first and fourth quadrant between these two lines. This is my first region. Suppose this is my second region that lies between the lines in first and second quadrant. Similarly, this is my third region that again lies between the lines, lies in second and third quadrant, and last this is my fourth region. I have to take some points from each of these region, and we will check which point satisfied this equation. Here I have just take a point 0 0. I think this is not sufficient to justify the graph of this region. Suppose you take a point from first region. If I ask where is point 1 1, clearly you will say this is point 1 1, x1 y1. Now if I say where is point x2 y1, suppose this is my x is equal to 1 and this is my x is equal to 2. Clearly this point x is equal to 2 1 is below this line, that is lies in the first region. So take this point x is equal to 2 and y is equal to 1 and substitute this point in the inequality x absolute less than or equal to y absolute, and check whether this point satisfied this. When you put x is equal to 2 here, this become 2 absolute less than or equal to 1 absolute. 2 absolute is 2, this is equal to 1. Is it true? No, this is false. It means your graph does not lies in this region. Graph is not here. Similarly, you can take another point in the fourth quadrant above the line. Suppose this is x is equal to 2 and y is equal to minus 1. Again, you will put this point in the inequalities. This is 2 less than or equal to minus 1 absolute, this is plus 1. This is again false. It means your graph does not lies also in the fourth quadrant here. So you can take different point from each of the region and can check which point satisfied this region. After observing, you will observe that this is the required portion, required graph given by this inequality x absolute less than or equal to y absolute here, enclosed by the two lines y is equal to x and y is equal to minus x here. Okay, next we move towards the graph of this inequality x absolute plus y absolute less than or equal to 1. The associated equation of 1 is given by x absolute plus y absolute is equal to 1. Graph of 2 is represented in figure number 1. This is my figure number 1, that is a diamond shape. Now I have to make the graph of this inequality. The graph of x absolute plus y absolute is interior and boundary also, and boundary of a square. Why are we including boundary? Because here this is less than or equal sign. If this inequality is like this, x absolute plus y absolute less than 1, then this shows just interior of square. But here equal sign is also included. That's why we will consider also boundary. So the graph of this inequality is actually interior and boundary of this. This can be done by taking any test point inside the square region of our region number 1 and check whether that point satisfy this inequality or not. Take origin 0 0. We have When you put this point in the inequality x absolute plus y absolute less than or equal to 1, this becomes 0 absolute plus 0. This is equal to 0 less than or equal to 1. Yes, this is true. So graph is boundary and interior of the square as shown in the figure 2. So this is the required graph of this inequality. Okay. Next we move towards C part. C part is x y absolute less than or equal to 2 here. The associated equation of 1 is simply x y absolute is equal to 2. Graph of 2 we have already discussed in 14C part, that was the rectangular hyperbola in first and third and second and fourth quadrants. Because my inequality having the sign less than or equal to less than or equal type, so the graph will be inside and the boundary of these hyperbola, like as shown in the figure. Otherwise, you can take any points from each of the quadrant, first, second, third, fourth, and check whether these points satisfy the inequality or not. And you can also take any point outside the graph here, from here, and check are these points also satisfy this inequality. You will observe that none of the point outside the region satisfy this inequality. So the final graph is given by this. The last one is x absolute minus y absolute greater than or equal to 2. The associated equation of this inequality is given by this equation, and the graph of this equation is simply given by these four lines starting from the 2 0 and minus 2 0. Now similarly, as question number 1, we have again four regions. This is the first region, lies in first and fourth quadrant between the lines. First region. This is my second region, lies in first and second quadrant above x-axis and between the line. So this is my second region. This is my third region, again lies between these two lines, x minus x minus y equal to 2 and minus x plus y is equal to 2, lies in second and third quadrant. The fourth region lies in your third and fourth quadrant between the lines, minus x plus y is equal to 2 and x plus y is equal to 2. You have to take different points from each of the region and check which point satisfied this region. Firstly, take origin 0 0 and check whether it satisfies or not. When you put x is equal to 0 and y is equal to 0 here, this becomes 0 absolute minus 0 absolute greater than or equal to 2, 0 greater than or equal to 2, this is false. So graph is not towards the origin. It means graph is not towards the origin. Graph is not here, not here. Okay. Now take a point 1 1. Where is 1 1? 1 1 means first quadrant. This is point 2 0. So clearly this is point x1 y1. Point 1 1 is lies here, 1 1 in the first quadrant here. Now check whether this point satisfies the given inequality or not. When you put x is equal to 1, y is equal to 1 in the given inequality, this is y inequality, x absolute minus y absolute greater than or equal to 2. This point becomes 0 greater than or equal to 2, false. So graph is not between the lines. So graph is not here, not here, not here. Similarly, you can take a point here, x minus 1 plus 1, y plus 1. Again, this point will not satisfy. Take point 4 1. Where is x 4 1? This is 2, this is 3. Suppose this is my 3. This is my x is equal to 3 and here x is equal to 4. So this will be point x4 y1. It means this point is below this line, above the x-axis and below this line. When you put this becomes true, so graph is below the line x minus y is equal to 2 here. Similarly, if you take point 4 minus 1, this also satisfies this equality. So graph is above the line. Your point x4 y minus 1 will be here, x4 y minus 1 here, above this line. So finally, After testing different points, you can shade the graph of this inequality as. So graph of x absolute minus y absolute is given by this shaded region. And it completes our question number 14 and 15. I hope now you have a clear understanding of these two questions. Still you have any question, you can comments me, inshallah, I will reply you. If you find this video helpful, kindly like, share and subscribe my channel. See you in the next lecture. Take care. Allah Hafiz.